Hey guys, today we're going to solve LeetCode number 1582, special positions in a binary matrix. So we're given a matrix and we need to return the number of special positions in the matrix. And a special position is a position that has only one in its row and column. So for example, this is a special position. You can see it's the only one in its row and column. But this one is not a special position because it has another one up here in the same column. So the way we're going to solve this is we're going to traverse through the matrix 3 times. So the first time we go through the matrix row by row, and the second time we go through the matrix column by column. So at the end of this iteration, where we go through all of the rows, we're going to have stored in this special rows set the set of all row indices that are good candidates to find the special positions. Because we check if there is only one in this row, okay, then this is a good candidate for special positions. And we do the same for all of the other rows. And then we do the same for the columns. So we are like, okay, this column, this first column here is not a good candidate because we can find more than one in the same column. So that's not a good special position candidate. Then we go through this one and we are not finding any ones at all. So when we say, okay, how many ones have I found? It's only 0, so we don't add it to the special columns set. But then when we go through this one, this column, the third column, so with index 2, we see that it has only one value, and so we add it to the special columns set. So at the end of those 2 iterations, we're going to have special rows be the set of all rows with only one position with a truthy value, and the special columns set is going to be the set of all indices, all column indices with the column having only one value with it, which is truthy. Okay, now what we're going to do is going to loop one final time through the whole matrix, and we're going to check at every row if that row is a good candidate for only having one, meaning that it can have a special position. And if it is a special row, it is a good candidate for finding special positions, then we loop through all of its column. And if we find one column where we have a value, a truthy value, so a 1, we check if its column is also a special column. And if it is, then we increment result by 1 and we break, because we know that we are in a special row, so we don't have to go through all of the resulting columns. So we can just stop at the first one because we know that we aren't going to find any other one in the same row. So we just break and we go to the next row. Okay, so I'm going to show you that this works. The code is very repetitive here. We're looping through the matrix 3 times, but it's still considered O of n, where n is the amount of elements in the matrix. And the space complexity is O of n squared because we need to store the matrix in memory. Okay, so thank you for watching. That's it for today, and bye.